Okay students, now let's do this question. Okay, find the current through the 40 ohm resistor. Okay, so which is your load? Your load is the 40 ohm resistor, that is this resistor over here. So which means I have to remove this resistor. Okay, so let me remove it. After removing the 40 ohm resistor, comma, then your circuit will become like this, right? That is a voltage source with a resistor over here, then we have another resistor over here, then we have an open end, right? There was a resistor over here 40 ohm, now I removed it, so now this branch is open, right? Which means no current will be flowing through this branch. And over here this is a 10 ohm, this is 50 ohm, this is 10 volt, and this is 30 ohm. Okay, so since I have removed this resistor from here, the voltage across this two open end, right? The voltage across this open end is VTH, Thevenin's voltage. Okay, so this is the open voltage we need to find. This is the open source we need to find. So so what is the value of the, so since like I said, the which branch is open, then the current through that branch will be equal to 0. So here if you look over here, this is, if you are applying mesh analysis, this is I1, this is I2, this is I3, and this is I4, right? I1, I2, I3, I4. So in that case, since this branch is open, if you look over here, it is I2 current flows downwards and I3 current flows upwards, which means the current through this branch is I2 minus I3 or I3 minus I2, whatever condition you want you can take. So which means the current through this branch is I2 minus I3, which means after removing the 40 ohm resistor, comma, I2 minus I3 is equal to 0, or I2 minus I3 becomes 0, right? Because that is the current through this branch. No current will flow through this branch. Therefore, the current through the branch I2 minus I3 is equal to 0. Therefore, I2 is equal to I3, right? Now I2 is equal to I3. Okay, so now what I'm going to do is I'm going to apply mesh analysis, like a normal method. I'm going to apply mesh analysis, and then wherever if I see I3, I will change that to I2. That's all. Okay, so let me mark the mesh current first. Okay, this is I1, this is I2, this is I3, and this is I4. Okay, so therefore let me write the equation for mesh 1. We have here as I1 into 20, okay, and then we have I2, right? So that is minus I2 into 20 is equal to this I1, this positive terminal is generating I1, right? This I1 is coming out from the positive terminal, which means it is plus 25, right? This is the equation. Okay, maybe if I want, I can simplify this, right? Because all the signs are distributed in terms of 5, so which means this will become 4I1 minus 4I2 is equal to 5. Okay, so that's the equation for mesh 1. Next will be the equation for mesh 2, right? Equation for mesh 2. Equation for mesh 2. Okay, so in that case, what will be the equation over here? It will be minus I1 into 20. Okay, minus I1 into 20 plus, and what about I2? 20 plus 50, right? So it is plus I2 into 70 I2 into 70, right? And then remaining is this open voltage, and this current is flowing from a higher potential to a lower potential. See, it's going downwards from a higher potential to a lower potential, which means it is plus VTH, right? Because current always flows from a higher potential to a lower potential, right? So it's plus VTH. Plus VTH, that's it, right? There is no voltage source, so this is equal to 0. There you go. Okay, so yeah, so that means this is nothing but minus 20 I1 plus 70 I2 plus VTH is equal to 0. Okay, so now I'm going to write the equation for mesh 3. Okay, so equation for mesh 3. Okay, let me see the equation. So if you look at mesh 3 over here, we have, there is no I2 is not touching anywhere, right? There is no current over here, so I2 is not touching anywhere, so which means this left it only with I3. And what is I3? I3 is touching only this resistor, which means it is 10 I3. 10 I3. Okay, and what about this over here? This current I3 is flowing from a lower potential to a higher potential, right? Which is not what a current is supposed to do. A current always flows from a higher potential to a lower potential. But here, this current is going upwards. In this branch, it is going upwards. If it is assuming that it is going upwards, it is flowing from a higher potential to a lower, it's going from a lower potential to a higher potential, which means it is minus VTH. Minus VTH is equal to, and what about the voltage source? Yes, this I3 is coming out from the 10 volt. It is coming out from the positive terminal, or this positive terminal is generating current I3, right? It is generating current I3, which means, or is supporting the current I3. So it is plus 10. There you go, plus 10. Okay, but we all know that I3 is I2, right? So 10 I2 minus VTH is equal to 10. 10 I2 minus VTH is equal to 10. Okay, so now how do you want to solve this question? Let me see. Maybe we can add these two equations, right? Or how about we just add all of them? What happens if I simply add all of them? Now I'll add these two equations, because one is having plus VTH, the other is having minus VTH. So if I add these two, those VTH will cancel each other, right? Yeah, let's do that. So in that case, what I'm going to do is that I'm going to add, let me mark this equation. Now from here onwards, you can solve any way you want. Okay, I'm going to simply solve using the old school method, simply by adding or subtracting equation, whatever I see fit. So here I'm going to minus 20 I1 plus 70 I2 plus VTH is equal to 0, and then we have over here is 10 I2, okay, minus VTH is equal to 10. Okay, and if I add all of them, I will get, here it is 0, right? So it is minus 20 I1, and here it is 70 plus 10 is 80, so it is 80 I2, right? And this plus VTH and minus VTH will cancel each other, and you will get here 0 plus 10 is 10. This is the equation. Or in other words, you get is minus 2I1 plus 8I2 is equal to 1. Okay, this is the equation you got. What is the other equation you got? Is 4I1 minus 4I2 is equal to 5. 4I1 minus 4I2 is equal to 5, right? So which means if I want to use this equation, what I'm going to do is I'm going to multiply this equation with 2. I'm going to multiply this equation with 2. So what will I get? I'll get minus 4I1 plus 16I2 is equal to 2, right? This is what I'm getting. So I'm going to add both of them. So by adding, these two will cancel each other, and this will be 16 minus 4 is 12. So it is 12I2 is equal to, and here it is 5 plus 2 is 7. Therefore I2 is equal to 7 by 12 amperes. I2 is equal to 7 by 12 amperes. 0.583. Okay, so this is the equation for I2. This is the current for I2. So if I know I2, then I can tell you what is VTH, right? What is VTH? VTH is equal to, let me see, if you put VTH over here and if you put 10 over here, it becomes 10 I2 minus 10, right? Or in other words, this is equal to 10 into 0.583 minus 10, and you will get the answer as, let me see, 10 into 0.583 minus 10, and that is equal to minus 4.17. Minus 4.17, we have negative voltage, okay? Minus 4.17 volt. So that is the value of VTH, okay? Just remember, this is the first time you are getting a negative voltage, right? It's nothing, there's no much unusual about it. So it is minus 4.17 volt. Now I'm going to find the Thevenin's resistor, RTH. So to find RTH, I'm going to change the circuit, right? So which means if I see any voltage source over here, I should short it, and if I see any current source over here, I should open it. And here you have two voltage sources. One is this 25 volt, the other is this 10 volt, which means I need to short these two, right? So by shorting them, what will I get? Let me see. I'll get this circuit. It is short over here, and I have a resistor over here. Okay, then I have another resistor over here. Let me mark the resistor, 20 volt at 20 ohms. This is 50 ohms, and then this is the same. Okay, and the resistor across these 2 points, across A and B, is RTH, which is you need to find, and this is the 10 ohm. Okay, this is the 10 ohm, and this is the short, right? This is the 10 volt will be short. So this is short over here, short connection, and then we have a resistor over here. That's it. That's the circuit, right? This is the circuit you get. And what is this? This is 30 ohm. Yeah. Okay. This is 30 ohm. How to find the equivalent resistance of this? From here we can say that these two are all parallel to each other, right? Okay, fine. What about this? And also, what do you know about this? About these two? See over, look over here. Here you can see, if you have this, you have learned it in school, right? That is, current always flows through the least resistance, right? Current always flows through the least, or more current flows through the least resistance. Which means, if you look over here, in this side there are two branches, right? Two branches, both of them are parallel to each other, but one branch does not have any resistor, or the resistance is equal to 0, right? The resistance is equal to 0. So if the resistance is equal to 0, then no current will flow through this branch, right? Because this path is offering the least resistance, and since it is it's a short connection, right? This end of the resistor and this end of the resistor are shorted together because they are all in one connection. So this entire thing is just one connection, which means no current will flow through this resistor, because this is the easiest path for the current to flow, right? This is the easiest path, which means this resistor can be discarded. Since no current is flowing through the resistor, there is no need of taking that there is no need of finding the equivalent resistance by using that resistor, right? Because the overall resistance is equal to 0. Or what you need to do is simply take the parallel combination of these two branches, one with the resistance 0 and the other with the resistance 30 ohms. You will find that the parallel combination, that the total combination is equal to 0 ohms. So which means there is no resistor over here. Likewise, same story over here also. This branch does not have any resistor, right? Which means the resistance along this branch is equal to 0. That means all the current will be flowing through this branch, right? No current will enter this branch because this branch has a resistor in it, right? So therefore, all the current will flow through this branch, which means this resistor can be discarded. Which means you can remove, or you can discard this resistor and you can discard this resistor, which means your overall circuit will now look like this. This is is your circuit. This is that 50 ohm, this is that 10 ohm. 50 ohm and 10 ohm. Okay, see, this is how what we got. Okay, this is after, because this two resistor need not be counted because we have a short over here, which means no current will be flowing through these two resistors. So this is the remaining terminal. So what is this? This is 50 ohm as is parallel with 10 ohm, right? So which means RTH is equal to 50 into 10 by 50 plus 10. We have 500 by 60, which is 50 by divided by 6, which is 8.333 ohms. There we go. Okay, so now your circuit will become like this. Okay, that is, we have an RTH over here, and the value of the RTH is 8.333 ohms. And what about this VTH? If you look over here, the VTH is a negative voltage. It's a negative voltage, which means it's a negative polarity, right? Negative polarity means it's like connection like this, right? And this value is 4.17. So normally, if you want, you can put the battery the way how it was before, that is positive terminal up and negative terminal down. Like that you can place the voltage source, and then you have to write the voltage source is minus 4.17 volt. Okay, but nobody usually does that. What they do is they simply change the position of the battery. That's it. Negative potential, right? So now this is plus 4.17 because I have put a negative potential over here, right? So it is 4.17 volt. Now what was the question? Find the current through the 40 ohm resistor, which means my load was the 40 ohm resistor. So I'm going to put my load back to its place. So this is the 40 ohm resistor. Now I'm going to find the current through that. So to find the current, I is equal to or applying mesh analysis, I into 8.333 plus 40 is equal to 4.17. It's not 4.17, it is minus 4.17, because you see this current is going into the positive terminal, right? It is going into the positive terminal, or this positive terminal is not generating current, it is opposing the current, right? Because positive terminal usually is supposed to generate current, but here it is opposing the current. So it is 4.17 volt. Okay, minus 4.17, which means your answer is I is equal to minus 4.17 by 48.333. This is your answer. 4.17 divided by 48.333, and you get is minus 0.086 amperes. Minus 0.086 amperes. What does this mean? Minus means here, according to your circuit, you are assuming that the current is flowing downwards, right? It is flowing down from top to bottom, but you got a negative sign here, which means in reality, actually there is a current called as 0.086 amperes flowing upwards. It is flowing into the opposite direction of what you have assumed. That's why there is a negative sign over here. Okay, maybe if you want, you can write that. Negative sign means the current is going upwards. I'll write it. It's always good to explain the answer like this. Negative sign means the current is going upwards, right? Which means the current over here, right? The current over here, the 40 ohm resistor, it's actually going upwards. In this way, it is going upwards, right? 0.0486. So sorry, 0.086 amperes is flowing upwards. That's what it means. Okay.